obviously a lot of artifacts in history museums have metal within them or are made solely of metal. So we're going to look at some metals now. Two things to think about with metals. One is that they divide up into ferrous, i.e. ones that have iron in them, and non-ferrous, those that don't have iron in them. And the great test for that is using a magnet, because all ferrous metals will react with a magnet. So for instance, that's a piece of stainless steel. You can pick it up. That's a bit of wrought iron. You can sort of pick it up. That's a bit of tin plate, which is sheet steel. You can pick it up. But then, and you can pick that up because that is a bit of steel wire. But this, which is made out of aluminium, won't do it. Silver, none of those will. So it's an instant test. If you've got a mixture of artifacts or an artifact with a mixture of metals, you can quite easily identify which is likely to be which. So let's start with the ferrous metals first of all, the ones with iron in them. And the key two objects you need to think about are cast iron and wrought iron. Wrought iron is a fascinating material, now almost completely superseded by mild steel, but it has really quite interesting properties. It has a layered feel to it once corrosion sets in, that make it almost look a bit like wood, and that's because the way wrought iron is made is that it's hammered and folded in on itself a number of times so that you end up with like a sandwich almost of microscopic layers, and that gives it a degree of strength and malleability. What we have with cast iron, and this is a slug from a box smoothing iron. It's quite weighty, but it's also quite fragile. And you could, if you took a hammer to this, it would probably fragment. It's basically molten metal that's been put into a cast and left to solidify, but it has a much more crystalline structure, which makes it quite fragile. And so this really curious object, which is meant to look like a clay churchwarden's pipe, is actually made of quite high quality steel. And it's sort of designed to show that you can make these very long, thin structures of artifacts, which from a material that has normally sort of quite hard properties, really. And then later on, the beginning of the 20th century, development of stainless steels come in. And so you get something like this, which is a bone chisel made of surgical steel, which is very high quality, doesn't rust. And that really brings us back to the other way of easily identifying ferrous metals, is that they will develop what we call rust, which is this reddy brown, sometimes blackish corrosion. And if you see that on any piece of metal, then you know that at least there's some iron present. The final piece of ferrous material we have is tin plate. And this actually, it's not plates of tin, it's plates of iron or steel, which have then had a tin coating on it to inhibit any form of corrosion. This is a cheese tester, quite lightweight, and you can see the remains of a little bit of plating on the outside of it, but primarily it's basically a piece, and there's a small piece of corrosion there that you can see. So that's the ferrous material. We'll start with lead, which is a very heavy but quite malleable material. It often doesn't, it looks a bit lighter than this normally. This is a homemade plumb bob, often used in things like pipes for both gas and water. Because it's so soft, it's normally found, or more widely found, as an alloy in things such as pewter, which is where lead and tin and antimony have been put together to create quite a very similar sort of feel to the metal, but one which is harder and not prone to so much corrosion. If you cut this in half and let this corrode, you'd end up with a sort of white powdery corrosion on top of that. The other material that looks similar on this table is this, which is made of aluminium. Again, this is now quite corroded, so you get this greyish patina on it. If this got worse and worse, this would start to develop white flat flakes. In fact, there may be 1 or 2 little pieces there. What's interesting about aluminium, it's the first metal we've talked about here, or alloy, first metal we've talked about here, which can be dated. Although attempts were made in the 19th century to isolate it, it really didn't start to be smelted in any large quantities until the 1890s. And so as a result, anything that's mundane like this, that's made of aluminium, is likely to be 20th century rather than anything else, anything earlier. The other great metal that we have is copper, and a good example of this is this extremely corroded manila, which is a token that was used actually in the slave trade. But you can see that the green corrosion on the outside is a telltale sign of it being copper. And any alloy that has copper in it, such as brass, which is an alloy of copper and zinc, will also develop what I suppose could be classified as verdigris, which is a green corrosion. Silver, which is another, if you like, pure metal, doesn't corrode, but picks up a sulfite corrosion, so it will turn black. This is on its way towards some form of corrosion. Again, quite a soft metal used, and quite a precious metal, so obviously found in upmarket artifacts or jewellery, etc. The other alloy that we find, which is related to the leads, is this, which is Britannia metal, which is a refinement of pewter, which has even more sort of linear strength, so that sheets of it, in this case, are put upon what is actually underneath a tin plate base to create this rather nice caddy. But you also find a lot of what look like pewter teapots are actually made of Britannia metal, because you can get a much thinner metal which is better and lighter. What you also then find is that some of these metals can then be plated, and the earliest attempt at plating is probably found in something called Old Sheffield plate, where copper artifacts such as this would have sheets of silver burnished onto them. After the 1840s, the technique of electroplating silver onto base metal, such as copper, developed into what we now know as Sheffield plate. But also, Britannia metal had a silver electroplated onto it, and that's electroplated Britannia metal, or EPBM. And then last but not least, this fork is an electroplated onto something called nickel silver, which was developed again in the 18th century as a substitute for silver, and it sort of forms the basis of an awful lot of domestic, fairly cheap silverware. And again, that process of electroplating developed in the 1840s and 50s. So we've got a good range of materials here that illustrate how different metals look and behave. There's the sort of magnetic element that we need to keep in mind for the ferrous metals, the iron and steel. And then in terms of the alloys and their platings, you've got quite a wide range of materials. But again, corrosion in terms of copper will be telltale, not just for copper, but also for brass. And there's even for things like nickel silver, where there's a copper element in there, these will tarnish down to green as well.